Yes.
So, good evening, everyone. Welcome. My name is Muhammad Syam Akram, and I'm the founder president of Poultry Professional Society. And here I will be moderating this session. This is our third webinar that is related to the poultry lighting, focusing on the welfare and productivity. And our today's talk will be presented by our keynote speaker, Dr. Karen Schwall-Lardner. So before we get started, I'm just giving you a brief introduction of our today's speaker, Dr. Karen. Dr. Karen, are you on the board and you can hear me?
I can hear you, yes.
Okay, thank you. So before we get started, I'm just giving you the brief introduction of our today's keynote speaker, Dr. Karen. Dr. Karen Schwall-Lardner is a professor at the University of Saskatchewan, Canada, working with turkeys, broilers, and laying hens. Her work is often multidimensional, using production, behavior, and physiological indicators to examine how various management practices impact both the welfare and productivity of birds. Dr. Karen completed her BSc with thesis in equine behavior and her MSc with thesis on alternative housing systems for laying hens, and her PhD focused on the impact of day length on broiler production and welfare at the University of Saskatchewan. So during the time of and after completing her PhD, she managed the University of Saskatchewan Poultry Research and Teaching Center, giving her considerable research experience in the production aspects of poultry production. She's also heavily involved in teaching poultry sciences, including production and management behavior and welfare of poultry and other livestock species. So we welcome Dr. Karen for joining us today, and thank you very much. So, along with now we have our chairperson of this today's session, Dr. Gibran Hussain. Dr. Gibran Hussain is associate professor in the Department of Poultry Production at the University of Veterinary and Animal Sciences, Lahore, Pakistan. With more than 15 years of experience in teaching and collaborative research in the poultry industry of Pakistan, he has held a PhD in poultry breeding and production. Pakistan Poultry Association declared Dr. Hussain as the best researcher and presenter for the year 2019. Dr. Hussain was also selected for the Young Scientist Awards by World Poultry Science Association, WPSA French branch, in 2020, and was also awarded the prestigious gold medal by the WPSA Pakistan branch in 2023. So Dr. Gibran Hussain has published more than 100 impact factor research papers pertaining to the various aspects of poultry production. So now proceeding this session, I call on Professor Dr. Gibran Hussain to please give some welcome remarks to our keynote speaker and to the audiences who are attending this session today. Sir, please go ahead.
Thank you very much, Syam. Am I audible, Syam, please?
Yes.
So, honestly speaking, I have no particular words to Dr. Karen for her time and for her effort to interact with our students, especially considering her schedule and overall activities that I have gone through her profile, and I'm really impressed with the profile of Dr. Karen, and I do want to have my heartiest thanks and appreciations for Dr. Karen for her wonderful research and now for her effort to educate our students. So I would not speak anymore and I would not take any much time of all of you. Rather, I would request you to start the session of Dr. Karen as we are eagerly waiting, Dr. Karen. We really want to listen her and her expertise. So thank you very much, Sayam. And my special thanks to Dr. Karen, please.
So thank you very much, Dr. Gibran. So before we get started, we have just made a short video for just a 1-minute video for Dr. Karen work in the poultry science field. So I'm just opening that one.
I need to stop sharing then. There you go. Sorry.
Okay, no problem, Dr. Karen. Thank you very much, Dr. Karen Schwan Lardner again. And now the moment overs to you.
Okay. Can you see my slides?
Yes, Dr. Karen, slides are on the screen.
Okay, I'm just trying to put them into slide mode because it's being stubborn. My internet is having a very bad day in Canada today. I'm sorry, and everything's just gone.
Okay, no problem, Dr. Karen. Sure. I'm sorry, audience. I'm again putting my some words. We have a question and answer session at the end of this discussion, so you can put your question in the chat box as well. And at the end, our speaker will answer your questions, and you can also share your question directly to our speaker by the open session. Thank you, Dr. Karen. You can please share your slides.
Yeah, I'm really trying. It's one of those days. Do you ever have one of those days when nothing wants to work? Okay, can you see anything?
Yes, Dr. Karen. Yes, slides are on the screen.
Okay, it does not want, there we go. There we go. Are we good? Okay. First of all, thank you very much for the invitation to talk with your group today. It's very exciting to talk with people all over the world. So thank you for listening, and I hope I can answer some questions for you today. Mohammed asked me to talk about lighting, and I think one of the most powerful tools that we can talk about is the use of light or day and night in poultry production. It has a massive impact on productivity, on economics of production, but on bird welfare as well. And if that's what you're interested in, I hope you get quite a bit from this presentations. So I understand that there are different barn types all throughout the world. The picture that you see on this slide, I hope, and someone let me know if you don't see the slides changing. The picture that you see here is of a Canadian barn. So it is completely enclosed. It's a light tight environment, which makes it amazing for us to be able to make changes to day and night and those types of things. But this is also true for curtain-sided barns when people are using additional lighting systems. So if it's turning to night and people are leaving lights on in the barn, it has an impact, the same impact that it will on an enclosed barn. So I think the information will be relevant regardless of what the barn type is, unless you're totally in an outside environment. But for other barn types, commercial barn types, this should be relevant. So when we started our work looking at day length, we talked to producers all over the world. We worked with Aviagen on this production experiment or set of experiments, and we talked to producers all over the world, and we asked them, why do we use constant daylight, 23 or 24 hours of light, leaving the light on all the time for broiler production? And they had a really good answer. They said that when we use constant day length, birds could have access to feeders and drinkers whenever they wished, and so that should help to make them grow better. So the philosophy was when we put them on long day lengths or the lights on all the time, they can go to the feeders and drinkers whenever they want to, and we should have better growth. But in our research, when I come to the conclusions, I'm going to show you that's not what happens. When we give them the ability to sleep, it's much like you, they feel better, they'll grow better when we allow them to sleep in a dark period. They have so much better feed efficiency and improves bird health, and it makes a big difference to bird welfare. So I'd like to share with you the data that came to that conclusion. And those of you that are familiar with Aviagen will recognize this because their worldwide recommendation is based on this lighting set. So when we were doing this experiment, we wanted to use 4 different lighting levels. They were 14 hours of light in a day, 17 hours of light in a day, 20 hours of light in a day, or 23 hours of light in a day. So the darkness, regardless of how long that was given in one period. So we did not break them up. It was given in one period. And that allows us to chart our results to see where we get optimal performance. We did this 5 separate times to make sure we were very comfortable with the data, to make sure that Avigen had good recommendations, solid scientific recommendations to use across the world. So over 28,000 broilers in these experiments. We used 2 of their strains, the Ross 308 fast-growing bird, the Ross 708, the higher breast-yielding bird, to make sure that we were comfortable with making this recommendations for various strains. And we grew them to different body sizes. In Canada, in Saskatchewan, we typically market about 31, 32 days. Eastern Canada, about 38 or 39 days, and then in the US, 48 or 49 days. So we looked at them at various times. So again, we were comfortable with different market ages. And the darkness started from 7 days of life on. So let's just get into the data because that's the most fun part. So let's talk about performance first. What we found was that when we weighed these birds early on, when we gave them darkness, they were smaller early on. But because that allowed the skeletal system and the metabolic system to develop before that heavy weight put on, they grew better at the end. And by the time we sent them to market, birds that had darkness actually weighed more than birds that had near continuous light. That's so cool. So producers would be shipping heavier birds when they made sure there's a dark period for these birds to sleep. This graph shows us body weight gain from 7 to 32 days. That's that younger age that we talked about. Along the y-axis is the weight in kilograms, and then these on the bottom axis are the photo periods, 14 hours, 17, 20, or 23, as I mentioned. The yellow line shows us the 308, the fast-growing birds. The green line shows us the 708s, or the more breast meat yield birds. And this is amazing. By 32 days of age, regardless of that slower weight early on, we have heavier body weights at under 20 hours of light. So giving them a 4-hour dark period early on in life made their health better enough that they could actually weigh more. That's pretty cool. And it goes against what we heard when we first talked with producers about this. But as we go to those older ages, this is the gain over the 32 to 38 day period. Again, the graph is set up the same. Look at this. 1 7-hour dark period where they can sleep for 7 hours increased that body weight gain here. So we're seeing that compensatory gain growing even though the dark period is longer. In that 38 to 39 day period, a little bit of a difference in strains, but in general, we're getting body weight gains that are better under 14, 17, or 20 than that near continuous light. So that tells us in terms of body weight, we're getting better performance when we give them an ability to sleep in a dark environment. This is the body weight gains overall. Remember again, that philosophy was birds would grow better under 23 hours of light because they have access to their environment all the time. But at 32 days of age, heaviest body weight occurred under 20 hours of light, giving them some darkness. At 39 days of age, both the birds under 17 hours of light and 20 hours of light, with those dark periods in one piece, outperformed the birds that are near constant light. And look at this, that's phenomenal. Giving those birds a 10-hour dark period outperformed birds on the near constant light. So any of the treatments that we looked at where we gave birds a darkness outperformed those birds. And this was 1 10-hour chunk of dark period. So that's amazing. It tells us how important a dark period is for body weight gain in broilers. This is the effect by genotype at 32 days of age. There's so much data here. I'm only showing you a little bit, but the papers are available in a number of journals if you would like to look all of the other data up. But this graph simply shows us that regardless of which strain we're looking at, in general, we have a similar production period. So light is so important to the basic physiological functioning of an organism, including a broiler chicken. It is similar across strains. This is the 39-day period. We're seeing exactly the same shape of graphs once again. I mentioned to you that giving that dark period also improves feed efficiency in broilers. This is the gain to feed ratios over 7 to 32 days of life. So it's gain to feed. The higher numbers are better in terms of feed efficiency. And by 32 days of age, we see a lower value under 20, but pretty close under 23. Remember, by 32 days of age, these birds under 20 outperformed them, and that explains that little bit lower value here. They're just bigger birds. Much better under 17, even better under 14 hours of light. This is a 7 to 39 day period. Again, a little bit lower under 20. Once again, they're heavier, but giving more darkness improves feed efficiency. And when we come to the final conclusions, one of the things I'm going to say is that each farm might use a slightly different photoperiod program. In times when feeds are very expensive, it may very well make sense to go to these longer dark periods just simply by improving the feed efficiency. This is a 7 to 49 day period. And once again, we see the best feed efficiencies under those long dark periods. And in this case, these birds were significantly heavier than birds under 23 hours of light. So cool that we can improve a feed efficiency by just allowing those birds to have that dark period. When we tried to think, why is this happening? We did a number of things and we weren't sure why we got feed efficiency. This graph is really confusing, but that's okay. I just want to point out one thing. What we did in this case was we euthanized birds every 2 hours to look at how much feed was in the crop, in the gizzard, and in the gastrointestinal tract. So time is along the bottom here. This is the full crop weight. And you can see that the longer dark periods, birds eat more before night period than they do when they have a short, very short dark period. And so as a result of this, what we see, whether they had 1, 4, 7, or 10 hours of dark, the crop empties at exactly the same time. So those birds that have more feed in the crop before the darkness starts means that that feed sits in there for a much longer period of time, giving the gastrointestinal tract an opportunity to have better digestibility occurring in that GIT. And so that totally explains why feed efficiency is better when we have a long dark period. It sits in the GI tract for a longer period of time, allowing better digestibility. So cool. If we look at gizzard weight over photoperiod program, when we measured that, you can see I'm showing that exact effect. Birds have higher feed intake again under those long dark periods. And as we add more light to the photoperiod program, this goes down. So this explains the digestibility difference. Something that I always point out when I talk about this is that it is important that birds know when nighttime is coming. So they learn to eat before that nighttime comes. If anyone is going to make a change to a photoperiod program, you always make it on the morning period, never on the night, because they need that night, that recognition of night, to know when to eat more feed before the darkness period comes. That's so important. The other things we saw in terms of productivity is that darkness improves bird health, and we saw that in mortality in cull birds. This is the diagrams of mortality in culls, percent of birds placed. 7 to 32 days on the top right, 7 to 39, and 7 to 49 days. In general, the graphs are the same, so I really want to just talk about one that I circled in green here. So this is 7 to 39 days. Highest mortality occurs under 23 hours of light, and then it starts to come down, a little bit of a bump under 14 lights. Remember that at 7 to 39 days, both of these birds, the 17 and the 20 hour of light, are heavier and are outperforming birds on 23 hours of light. And usually we expect higher mortality in culls under heavier birds. Not the case when we make sure darkness is there. That bump, we think that 10 hours of darkness is too much, and we're getting that higher mortality there. So this is what we're really interested in, the 7 and the 4 hours darker period, particularly the 7. And we think that this is because that early life period, when that body weight was lower under these photoperiod programs, what that did was give the skeleton and the metabolic system, the heart, for example, an opportunity to grow and develop before all that extra compensatory gain came on. So giving them that slower growth rate really makes a difference in terms of mortality in these birds. And we see that when we look at the individual causes of mortality, both for the metabolic diseases, sudden death syndrome and ascites, and also for leg deformities. This is the mortality in culls due to skeletal defects. Lighting programs on the bottom, different periods, 7 to 32, 7 to 39 in the green, and 7 to 49 in the dark brown, and percentage of mortality and culls due only to skeletal defects on the y-axis. And you can see as we go up, as we add light into this photoperiod program, we're getting higher skeletal defects under long photoperiods. So that completely backs up our hypothesis that we're making this big difference by giving them that slow growth early on and allowing that to adjust later on in life. Whoops, our meeting is ending soon. Particularly metabolic and skeletal.
Yes, I'm interrupting you, Dr. Karen. We have
I'm listening.
Initially we have a basic Zoom meeting plan. So we will be joined after the end of this meeting. If the session will be continue, then we will be joined by the same link as the meeting will be ended. Right?
Yeah, I'll hurry and just go over the important stuff. When we talk about mortality, we've already talked about a number of causes, but we also see mobility in the live flock is better. This is gait scoring. The higher the value is, the poorer the mobility in the flock, and likely the more pain those birds are in. And you can see adding darkness improves that mobility. It also changes behavior. Walking behavior gets birds from A to B. So despite long dark periods, we see more walking, improves bone, improves muscle under these photoperiod programs. Feeding behavior, although we thought they feed more under 23 hours of light, they do not. They actually feed more or spend more time at the feeder when they get a dark period. So that tells us, all of this data tells us that 23 hours of light should never be used for photoperiod programs. We also looked at diurnal rhythms, and the function of that is to coordinate behavior and physiology. For example, you eat supper at the same time every day. We looked at melatonin, which is a neurotransmitter important in growth hormone immune function and association with sleep. And what we found is birds under 14, 17, and 20 had the perfect rhythm that we like to see. Birds under 23 had no flock rhythm, and that also can affect immune function and growth hormone. It's another reason why we're seeing poor performance under 23 hours of light. We think sleep deprivation is part of this, in that the birds are completely awakened over and over again when they have that long dark period. We also saw poor rhythms in terms of behavior. So again, under 20 and 23, no rhythms. So some birds are trying to sleep, other birds are trying to feed. That lack of rhythm in the flock means that disruption could happen, and that has negative consequences on bird health and bird mental health. We see that in a number of different behaviors. So to conclude and give you a few minutes for questions, that tells us that 23 hours of light, leaving the lights on, if there are lights in barns, leaving them on is not okay. We have poor feed efficiency, higher mortality, lethargy in terms of behavior, poor diurnal rhythms, and as a result, it should not be used. Long dark periods may also not be the best, but that 4 to 7 hours is going to be optimal in terms of giving a dark period. The reasons were that early growth that I talked about, the physiological changes, including melatonin and the importance of sleep, and the increase of exercise we saw under there. So should every farm have the same lighting program? Probably not, but we should have a minimum of 4 hours of darkness. Let those birds sleep in the dark period to make an improvement on all of those other factors. So that was a very quick end to that presentation. I'm sorry about that, but we started almost 15 minutes late, so it was difficult to catch up.
Okay, thank you very much, Professor Dr. Karen, for presenting such a wonderful lecture. So now we have a question and answer session, and our audience can ask a question directly to our speaker as well, and you can write your question in the chat box as well. Few questions are in the chat box. First question is from Hafiz Muhammad Rauf Hassan, that why do chickens need light, and how can light affect the production of eggs?
A very good question. So the question was, why do chickens need light and how can light affect the production of eggs? So I think I've explained much of to you about why they need light. They need light for diurnal rhythms, and they need light to feed, and they prefer bright light systems. In terms of eggs, remember that table eggs, their physiological system works much like wild birds in that light, longer day lengths is what starts physiological production of eggs for birds. So when we increase the day length on a 19-week-old flock of laying hens, for example, that's what causes them to come into egg production. The difference between day and night is necessary for birds that are going to lay eggs. They must have over the critical day length of 12 hours to be able to lay eggs. So for egg production birds, it absolutely is essential for them to have a day period and a night period. May I keep going with questions till we end?
Yes, Dr. Karen, you can, sure.
Okay, the next question that I see in the chat is what color of bulbs should be used for layers and recommended intensities. So there is some work looking at bulb color, and the philosophy or the what is being shown for layers is that light color with a red spectrum tends to go through the skull. So light can penetrate through chicken skull and affect the pineal gland at the top of the brain. And that all stimulates the reproductive hormones a little bit more. So if I were going to change from white and go to a color for those birds, it would probably be somewhere in that red spectrum, not the blue, not the other end. In terms of light intensity, they have to be able to understand day from night. So the breeders should give you specific intensities for their strains, but it's in the ballpark of 10 lux or brighter that they should have for that. And I think Assad answered that question afterwards. The hormones become active during light, yes. Ooh, Hafiz asked me what light is best for chicken, and I'm not sure what that question is. Day length we've talked about. I'm not sure if you're looking for light colors. If it is light colors and we're talking about broiler chicken.
I think he's talking about the kind of light or the type of light, like we have light emitting diode LEDs and incandescent lights. So
yes, so there
which
are
light is
a
best?
few studies showing that LED bulbs few studies showing LED bulbs are better. They're just so much cheaper and they last longer, cheaper to run and they last longer. So most of our producers are moving to LED bulbs.
So
Daniel asked, should the giving of
yes, Dr. Karen, proceed. Yes, you can proceed.
should broilers be given 4 hours from a day of age? We give our birds 2 hours on day 1, 3 hours on day 2, 4 hours on day 3, 5 hours on day 4, and 6 hours on day 5. That's how we make our changes there.
So now we have just 2 minutes. Now I request Dr. Gibran Hussain to please conclude this session and give the certificate of recognition to our today's speaker, Professor Dr. Karen. Dr. Gibran, please go ahead.
Thank you very much, Sayam. Honestly, I'm really impressed the way Dr. Karen has
Dr. Gibran,
interacted with our students.
Dr. Gibran, can you please open your mic, camera?
Yes, I have opened the mic. Can you listen to me?
Sir, can you please open your camera, video?
A bit difficult because here the signals are very poor, and if I turn on the video, then it will be difficult to interact with you guys.
Sure, proceed, please.